In this amazing video, we will continue our discussion of functions and fold in more information about data types. Log on to SSMS, connect to our server, use your personal credentials. We will be creating a table in your personal database for you to work with. Here is the script to create the table that we will use in this slideshow. Grab a copy of the script, flip over to SSMS, paste it in, change the name of the database to your database, execute the script. Make sure you don't have anything highlighted, where it will only execute what is highlighted. That will create a table in your database. My database has a lot of tables. You can see that there is the table we just created called data. Go back to the slideshow. On the following slide, grab that code, change the name of the database. This little snippet of script will populate the table with a little bit of data for us to work with. Execute that. And I spelled it wrong. Let's try the correct spelling of my database. Now there are pieces of data in the table for us to work with. 2 rows. Once you've got that finished, let's flip back over to the slideshow. And let's talk about the char index function, a very valuable function that we can use to search through a varchar or any kind of string for a particular character, and then we can retrieve the index of that character. You can grab this little snippet of code or you can type it in to SSMS, whichever you prefer. We're not using a table yet. We're just demonstrating using a couple of string literals, strings enclosed in quotes, how this function works. In this particular example, we are searching for an occurrence of the letter B in the string A, B, C, D, E, F, G, H, I. That returns a 2 because B is the second element in that string. It's the second letter in the string. Let's be curious. Is this function case sensitive? What happens if I search for a lowercase b? I also get a 2. We can see then that this function char index is not case sensitive. It will locate an uppercase b if you search for a lowercase b. On the next slide, we'll jump into our table a little bit. In this little script, the first thing we do is print out all the data in the table just to see that there's something in there. And then we do a char index function for the letter B, but instead of searching through a string literal, we search through the value in the column 1 field of that table. Let's grab that. When we run this, we will get 2 windows in the Results tab. The first window is select star from tdata, all the rows, all the columns in that table. The second window is the result of the second line in the script. Select char index B, looking for the letter B from the column called column 1, the field called column 1 in the T-data table. We can see in the first window that we have two identical rows here, and column 1 contains the same thing in both rows. When we execute the char index, we get a 2 because we get a result from each of the rows in the T-data table. It processes each row in the table and executes the char index function against the column 1 field in each row of the table, and we get 2 rows in the result set. We could certainly, if we wanted to, add an alias. Therefore, it looks a little bit friendlier when we run that query. If I highlight that script, click execute, now I get a nice friendly name, target, as the name of that column rather than just a no-name column. Notice that the indexing starts at 1. In other words, the first letter in the field is index 1, the second letter in the field is index 2. That's intuitive to most people who aren't computer savvy, but if you've had any programming languages such as Java, C++, C#, you may have learned that indexing into an array, which this certainly seems to be like what we're doing, starts at 0. The first element in a string in Java and C++ and C# is element 0. The second element is element 1. But that's not the way it works in SQL. In SQL, the first element is element 1. We don't index from 0, we index from 1. If you're not used to other programming languages, then this will make perfect sense to you. You won't have a problem. If you've already convinced yourself, if you've already trained yourself to think that indexing starts at 0, here's an example where it does not start at 0. Just makes our job more interesting, gives us job security, because we have to understand things that most people don't. When we go back and forth between programming languages, we have to stop and think, does indexing start at 1? Does indexing start at 0? It just adds to the challenge of our profession. Let's be curious again. What if char index fails? And when I say fails, I mean what if it doesn't find the value that we are looking for? In this particular case, we're looking for a Z, and there is no Z in that column 1 field in that table. When we run that, we get a 0. A failure then is not all that dramatic. It doesn't crash, it doesn't generate an error message, it doesn't quit running, but we do get a 0. Now we can see the use of the number 0. It's not an index into a string, it's an indication of a failure to match. Since there was no Z in the column 1 field, we got a 0 back when we ran the char index. We got 2 rows, 2 zeros, because there were 2 rows in the T-data table. When you're learning about these functions, then do some experimentation. Think about different ways you can break it. Think about different ways it might work, and try them out. That will build your confidence level and increase your experience when it comes time to use these functions in the real world. Another function we use quite often is substring. Substring takes 3 arguments. The first argument is what we are searching or processing. The second argument is the index we're starting from, and the third argument is the length. In this case then I'm saying process the information in the column 1 field, start at index 1, and give me 2 characters. And you can see we get AB when we do that. We can try this in SSMS. 2 rows of output, 1 for each row in the data table, and we get the same result each time. If you hover in SSMS, you will get some context-sensitive help. It tells you that substring is a built-in function. The first argument is the expression you are searching. In this case, we're searching the contents of a column in a table. Where you want to start searching. In this case, we decided to start searching at column 1. And then the third argument is how many characters you want to grab. Start at column 1, grab 2 characters, and return that as the result of the function. If you're more curious, then you might wonder what happens if substring fails. What if we start at a place where the length of the string does not exist? Or what if we ask for something that we can't have? Let's grab those. In the first script, we're saying start at index 99, the 99th character from the beginning of the string, and there is no 99th character. The string is only A, B, C, D, E, F, G, about 7 characters. If we try to go to 99, will the program blow up? Will we get an error message? Will it fail? What will it do? It's always good to know what the boundary conditions are, what could go wrong. And we get what appears to be blank. Is it null? Is it blank? Is it empty? Is it a bunch of spaces? We're not sure because there just appears to be an empty field. Being more curious, I'm going to do the same substring search, but I want to know how long that field is that was returned to me. I'm going to execute the len or length function that tells me how many characters are in a string. What I'm saying here is execute the substring, start at index 99 for length 1, and then whatever that returns, tell me how long that is. I get 2 windows. The first window is the first script that I ran up here, which we talked about as being some mysterious empty field. The second window is this len of substring, and I can see that the length of a substring in this particular case is 0. It appears to be a 0 length string. Let's be more curious. What is the length of a null string? What will I get if I do that? I get null. Good, that tells me that I did not have a null string in the previous examples because I would have gotten null when I ran the length function on the null. It's interesting then, keep that in your back pocket, in the back of your mind, that if you run a len or a length function against the null symbol or the null string, the return value you get is null. We're seeing that these functions are fairly well behaved. They don't crash, which is interesting, but they do return values that are a little bit beyond what you might expect. So make sure that you're aware of what these functions do and make sure that you're curious and you debug your code as you go, possibly debugging it 1 line at a time or even 1 little phrase at a time, so you know what the values are that are coming back from these functions and you're not surprised. It's much easier to debug a simple select and then build that into a more complex select than it is to write a large complex select statement and try to debug it at the end when it surprise doesn't work. Start small, go slow, debug frequently, and you will have a much better experience and you'll be much more successful. You don't have to generate huge amounts of code and then try to fix it. Generate small amounts of code, get them to work, and then combine those small amounts together. Here's another approach on what we just talked about. Instead of trying to do a select on a null, I added another script where I'm doing a substring and I'm asking for information that I know is not available because there is no column 99, there is no index 99. And then I'm going to do an isNull on that value that is returned from the substring. The isNull function is something we'll get to later. It's a little bit farther along in the reading. But what the isNull does is it looks at the first argument, and if it's null, it returns the second argument. Just another way to check for null. I kind of like my way better because select null was pretty straightforward. This is a little more complex, but at this point in your progress, I would expect you to look at that line of code, and I would expect you to figure out what it does by using your friend Google, using your book, and trying it different ways in SSMS. Just because we haven't seen this before doesn't mean you don't have to spend a little bit of extra time to figure out what in the world it might be doing. So be brave, be ambitious, and be ready to jump in and figure things out if you're not quite sure what they are. Here's a very useful function. We're combining char index with substring. This lets us scan through a string, in this case a string literal, search for an instance of a particular string, and then use that as part of the argument to substring. Let's grab this. This returns world. Now, why does it return world? When we're trying to figure this stuff out, let's start in the innermost parentheses, just like you do in an arithmetic or a math class. Start inside the parentheses and work our way out. Inside the parentheses is this expression, which is a function call to char index. What does that do? The beauty of SSMS, remember, is we can highlight something, and as long as it's syntactically correct, whatever we've highlighted, we can run it. And this was not syntactically correct. Why is this not syntactically correct? Take a moment to think about it. Okay, a moment has passed. The reason it's not syntactically correct is although the function is syntactically correct, it's not a correct SQL statement. It needs a select. Copy. That is syntactically correct. We couldn't get the select and just the char index function together because I can't highlight select and then highlight this, or if I can, I don't know how in SSMS. Therefore, I had to break out the char index function and then add a select to it. That works, and I get a 7. Okay. We go back up here, then we can see that this function call will return a 7, and the reason is because if we start counting, the H is 1, 2, 3, 4, 5, 6, 7. The world, the W, is the 7th character. That's why we get a 7 here. That 7 becomes the second argument for substring. If we hover over substring, we can see that substring wants an expression, it wants a starting position, and it wants a length. Our expression is hello world. That's what we're going to operate on. Our starting position will be the 7 returned by the char index, and the 5 will be the number of characters we want to extract from substring. Let's get rid of this. What we're doing here is we're finding the location of a string inside of another string using char index. Then we're using substring to extract everything beyond the beginning of that string that we searched for. We do this a lot. Search for a string inside another string, and then grab that string or part of it or everything beyond it by using one function char index nested inside another function substring. File that one away. You will use that quite a bit. It will help you. Here's a variation on what we just did using char index nested inside substring, and we are finding a space using char index, then we're grabbing everything after the space. This is a way then to get perhaps a division between first name and last name if we know there's a space between first name and last name, if we know there's a space in a phone number, if we know there's a space in some type of data that's being given to us. We can use char index nested inside of substring to extract part of that string using the space as a delimiter. And I use 999 as my length argument. You could use a bigger number or a smaller number depending on your application. I just chose a nice big number to be sure that everything beyond the space would come out with a substring. You should grab a copy of this, take it over to SSMS, and work with it. What happens if you make 999 excessively large? What happens if you try that? Something you should be curious about. Do you get an error message? Does it work? Does it make sense? Can you explain why you get the results that you get? What happens if you subtract 1 instead of adding 1? What do you get then? The more things you try, the more experimentation you do, the more confidence you will develop and the better understanding you will have of what we're doing. Here's one that doesn't work. If you look at the structure of the data table that I provided, the field called column 4 is an integer. And I can't do a substring on an integer. Grab that code. And that fails. We get no results. We just get a nasty message from SSMS. That's actually SQL Server that threw that message, and then SSMS just displayed it for us. The error is argument data type int is invalid for argument 1 of substring function. You can't do what we tried to do. It is impossible to take a substring of an integer. Now in our brain we can. If we look at the contents of the data table, column 4, it displays in a kind of a stringy way. It looks exactly like column 3, which is a string, looks like column 2, which is a string, but we can't do a substring on it. If I want to, which I very well might, I might want the first digit or the last digit or the second digit, who knows, different applications might require that. I need to do some kind of workaround. I could recreate the table and convert that column to a string. That would be an absolute disaster, because then I would have probably broken hundreds of other scripts and confused other people and caused no end of problems. But instead of actually changing the table structure to meet my needs, I can use a function to convert an int to a string and do a substring on that converted integer. And there it is. A nested function again. The convert function is nested inside the substring function. The first thing I do is convert column 4, the contents of column 4, to a varchar, which is a string. Then I execute a substring on that, starting at index 1, going for a length of 2, and that gives me the 12, which are the first two characters, or the first two digits, I guess, in that integer value. Again, another example of why it's important to know how to do data type conversions. We can't do substring operations on numbers, but we can convert numbers to strings and then do substring operations. Just like we can't do math on strings, but we can convert the strings to numbers if they contain numbers, and then do math on those converted numbers. Here's a little quirk that I like to talk about because most people don't have a grasp, not having a lot of computer experience, with the way numbers are stored internally. And it's important that this seed is planted early, that numbers often are not what they appear to be. In this case, I take the string 001.001, stored as a string. I convert it to a real, which is a data type. I take the same string, 0.001, stored as a string, convert it to a float. At first glance, those should be the same. 0.001 converted to a real, you would think, intuitively, is the same as 0.001 converted to a float. It's not. The results are different. Let's grab this code. This code gives us some unexpected results. We get a very, very, very small number, 4 by 10 to the minus 11th. So a decimal point followed by 10 zeros followed by a 4. 0.00000000004. Tiny, tiny number. But it's still a number. We would expect 0.001 minus 0.001 to be 0, but it's not. And that tells us that these two numbers, stored as a real and stored as a float, are stored slightly differently. And I'm communicating this to you to scare you, to make you aware, to make you nervous about what you do with numeric values. You have to make sure the data types are correct, and you have to understand the precision that is used to store these data types. We won't go into great detail here, but your takeaway from this should be that you have to be careful and you have to understand what you're doing, and it is very dangerous to mix data types in the same expression. In this case, I had a float and a real. I subtracted one from the other after converting both of them from the identical character string, and I got a number that was not 0 but was very, very close to 0. What does this do? Take a moment to look at this. Moment is up. We are using the if function, which we talk about a little bit farther down the road. It says that it is converting 0.001 to a real, converting 0.001 to a float, and testing them for equality. Are they equal? If they are equal, it returns a y. If they're not equal, it returns an n. You can see the result of that if expression returns an n, meaning that they're not equal. This is the same thing I did in the previous slide. Instead of printing the result of that subtraction of those two numbers, I'm just using a function to detect the difference between those two numbers. Hopefully you're in panic mode by now and you're terrified that maybe SQL Server is broken, but it's not. This is all predictable, understandable, deterministic. We know that it's going to happen, we understand why, and we can tell you exactly what will happen when we do this. Now, when I say we, I'm talking about the computer scientists who design SQL Server and who understand the nuts and bolts of it, and the computer scientists and computer engineers who can explain how a real number is represented and how a float number is represented. That's not us. That's beyond the scope of this course. But as long as you are aware that there is a problem and you can't just go mixing data types in an expression without understanding what might happen, then your takeaway is sufficient for this course. Here's a fix. Here is how we can make this expression work. We add a little epsilon. In this case, the epsilon is 0.0000, I don't know how many zeros, 1. A very, very, very small number. And if the subtraction of the real number from the float number from the real number is less than that epsilon, we can safely say those numbers are almost but not quite equal, close enough to equal, it doesn't make any difference. That's how we work our way around some of these problems, is by building in a little bit of error. And when I say we need a little epsilon, that's a reference to a Greek letter that we use in mathematics to represent that little bit of tiny error that creeps in, or that little bit of correction that we apply. So epsilon, Greek letter, indicating a little bit of error correction that we put into a mathematical expression to make it work out the right way. This is computer arithmetic. This is the nuts and bolts of the machine. It's not just SQL Server. It's Java, it's C#, C++. Because in the real world, 0.001 makes perfect sense to us as humans, but 0.001 is problematic when we try to represent it with ones and zeros inside a machine. We're not going any deeper than that. If you'd like to know more, a starting point is the IEEE 754 standard for floating point arithmetic. This is a starting point for some of the problems that we've just talked about, because this is how numeric values in floating point are represented in a computer. Way beyond what we're doing here, but if this is the kind of nerdy information that excites you, you want to know more, download the IEEE 754 standard, dig into it, and have a great time. Before I adjourn, I want to point out that even this isn't exactly, let me flip to the next slide, sorry. I want to point out that this even isn't exactly correct, because we are assuming that the second conversion is a little bit smaller than the first conversion, and the result of the subtraction is a positive number. To do this the exact correct way, and I just want to make sure that we're doing things a little bit more precisely, I'm going to need to convert that to absolute value. That way it doesn't matter if one number is a little teeny bit bigger than the other, or if they're vice versa. That applies the epsilon correctly. Regardless of whether the first number is bigger than the second, or the second number is bigger than the first, I still can tell if I'm smaller than that epsilon. And ABS is the function that returns an absolute value. That's the end of the slide presentation. I hope you enjoyed it. I encourage you to be inquisitive, play around, try these functions on data tables, try these functions on literal values, and you will develop a high level of confidence, and you will enjoy this work a lot more.